questions below CCNA. Like, how many types of networks are there, guys, based on your existing experience or knowledge? How many types of networks are there?
LAN, WAN, WLAN.
So local area network,
Mm-hmm.
campus area network, wide area network. Three networks are mentioned.
Okay. Why not MAN, Metropolitan Area Network, or PAN, Personal Area Network?
LAN and personal area network both are same, right?
So, and CAN is different?
No, CAN is for a campus, college campus, like that. CAN,
Okay.
campus area network, and local area network is within the homes, and wide area network is the internet, as an example. Yeah.
Okay. And MAN is also LAN and PAN is also LAN, right?
I don't know, sir. Like,
Okay,
yeah,
okay.
I mean, whatever I know, I said. That's
How
it.
many user can be there in one LAN? How many user can be there in one local area network?
A lot
Not
of them,
support.
as much as we want. It's just that it's not going to be scalable, but we can have as much as we want.
Okay, as much as I can. Okay, so then how we divide network on the basis of what? We didn't divide network on the basis of user, right? So that's not matter how many users are there in LAN or how many users can be there in LAN. That's not matter. Great. Then
Mm-hmm.
based on what we are deciding that this is LAN or WAN or MAN, CAN, PAN. Technically, we have only two types of network. In terms of technology, we have only two types of networks, LAN and WAN. How you will identify that this is LAN and this is WAN?
Private and public IP ranges.
Okay. So all the public is WAN, all the private is LAN. Is it like that?
Yes.
No, sir. Any company can also buy their personal public IP.
Exactly. Exactly. So we divide network based
And
on.
also, if
Mhm.
I wanted to say also if there's there's no presence of routers, we can talk about when.
Hmm?
If there is no presence of routers, we cannot talk about wide area network. That's what I mean.
Okay. 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 Anything else?
The devices which is connected, you can communicate within the network is called local area network. And the devices which can communicate with another network, that is considered as a wide area network.
Okay. 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 By the way, this is interview question. How many users can be there in one LAN, local area network? Even interviewer had asked this question to me around 5 years ago.
Hmm. And what was the right answer for that?
My right answer was
Hmm.
we didn't divide network based on user. We divide network based on domain, based on
Okay, great.
area. So if
Okay.
my network is implemented in a small geographical area,
Mm-hmm.
that will be always considered as
LAN.
LAN. Like
Mm.
implementing network in a building, between two building, three building, four building, campus, and implementing network in large geographical area will known as WAN. These are
When.
topology
Mm-hmm.
defined types of networks, right? Types of network. So we have only two types of network. One is LAN, one is WAN. Rest all are human defined. We have defined some networks like CAN or PAN.
Okay.
PAN, CAN, MAN, right? These are human defined networks. Like CAN is nothing but the multiple LAN. Multiple LAN can be considered as CAN. Multiple CAN can be considered as MAN, right? And when we are connecting few devices, like let's suppose you have connected two mobile phone through Bluetooth to just share one photo, that will be considered as
10.
PAN. So these are human defined network. We have defined it. Technically, we have LAN and
WAN.
WAN. Sir, can we also discuss on the cable type? Yes, we will discuss on the cable type as well. Okay, so this is type of networks. Remember, we have only two types of network, LAN and WAN.
WAN.
What is the difference between network and networking? Network and networking.
Well, a network is a set of equipments that are connected together and in order to share resources. That's the network. Now, networking is a
Mm-hmm.
Working
it's
network is called as networking.
yeah. Networking is the all all the all the techniques, all the methods that we use
Mm-hmm.
to make a network work. If I can put it this way, all the techniques and the rules that we put in place in order to make networks function properly.
Okay, okay. So if I have two computer, let's suppose just I have purchased these two laptops from the market. Right? I didn't
Mhm.
configure anything. Two laptop and one Ethernet cable. And I have connected them like this. Can I say this is a network?
No,
Why no?
because they won't be able to communicate since there's no configuration behind.
Okay, so but to both the laptop has already Windows operating system.
But they won't be. The purpose of a network is to share resources. But if they connected and they can't talk to each other, I don't think it's network, unless I'm mistaken.
Hmm.
Suppose it's connected, then it's a network because
Okay.
they can talk to each other.
Even if you don't put an address or anything,
So two types
if
of address are there. One is IP, one is MAC. Later you will also learn
Mark.
the port. Port is also one kind of address. For now IP and MAC. Who will assign IP address to the devices
The network engineer.
and MAC address?
It comes by with the producer, the manufacturer,
That
The
means both
vendor.
the laptops has already
the
the MAC
vendor.
address.
Yes, it's in the it's burnt into the. No, we still need the IP address.
We still need the IP address. MAC address alone is not sufficient, right? So yes,
It's
this
not
is, you
sufficient.
can say this is network, but this network is not usable right now. This network is not
Mhm.
active. You can't send any data
Okay.
from this PC to this PC. By default, your machine has one address, that is MAC address, which is the physical address. And soon we are
Mhm.
going to talk about MAC address as well. Let's suppose this machine has MAC address A, this machine has MAC address B. But to send data, to communicate, they need logical address as well, which is the IP address. And for that, either you can manually define the IP address or you can set up a server, DHCP
DSCP.
protocol, right?
Uh,
Correct? This is
yes.
network. So my network can be live or it can be dead, like this. Right now this network is not live, not running. And networking, the process.
Sir, how do you, sorry, sir. How do you differentiate between a live network and dead network?
So you are not able to send data from PC A to PC B.
Okay, since they don't have IP address assigned, it's a dead network. Okay.
Because of any reason, maybe this cable is faulty. Because of any reason, if it is not working, if you are not able to send data, that means there is no connectivity. That network is dead. And this
Okay,
is
sir.
a
It's not. It's
smallest network. World smallest network is connecting two devices. And largest network, you will see the largest network. This is
Yes,
your
sir. And yes, sorry, sir. Like, let's say if two devices are there, we are connected with them with the wire. Now we have IP address also assigned. Now, can system A communicate with system B, or do we need any other extra configuration? Then only it will start communicating.
depends which devices are connected.
System A, computer, let's say desktop A, desktop B. Both of them are connected with the wire, and both of them have MAC address and IP address. Now,
How many of
can
you
we
know the
call?
answer of this question? I have
what's
purchased
his
two
question?
laptops from the
Hmm.
market. I have connected them and configured the IP address. They can communicate or need extra configuration.
They
Can
can
communicate.
communicate. They can.
Every day we are using it, right?
Yeah, they can communicate.
100% they can communicate. They don't need any extra configuration.
Mm.
Okay, sir.
The process of designing and construction of network is called networking. The process of constructing and designing the network can be called as network. In a secure environment also, you can say in secure environment
Environment.
is called networking. Because when we talk about the advantage of network, then security is also one advantage. With the help of network, when you are sending data, most of your data is
Secured.
encrypted. Yes, encrypted. Okay, tell me some advantages of network. Tell me some
Yeah,
advantages.
the main advantage is sharing resources.
See, before
Sharing
network
of
also we
data.
were exchanging the data, correct? Before network, when there
Ex-
was no network, then also we were exchanging the
the data, yes.
data.
Speed.
Speed.
Speed, sir.
Okay.
Yes, speed is the,
One advantage. Okay.
yes, biggest advantage. Second,
Okay.
it can be cost
We,
effective.
Security. Security.
Yes, security cost effective. Yes or no?
Cost. Yes, cost effective. Yes.
Today,
That too.
how easy it is to send data from one country to another country. Earlier,
Very easy. Hmm.
earlier it was
Was
difficult. Security,
yes. Hmm.
right? If I am sending letter through postman, there is chance that they can read, right? They have authority.
Mm.
They can open your letter, they can read.
You can read it.
Even nothing is 100% secure in the world. Nothing
Hmm.
is 100% secure in the world, but through network, your data is more secure. And I am getting echo, guys. Please put yourself on mute. Someone from some side, I am getting, yeah, now it's okay. Then speed, cost effective, security, reliability, right? If you are sending some message through WhatsApp, you will also get the confirmation that message is delivered or not. So these are some basic advantages of sending information through network. This is network and networking. This is type of network. Some more things are there, like the basic components of network. Who will tell me the basic components of network? Like to send some data through network, what are must be there?
Okay, you first need at least two equipment,
Yes, tell me the name.
like a network device,
Like
a network
the sender
device,
device should have one device.
and the receiver one device too.
Exactly. Sender and receiver both should have one device. Then there should be
Okay,
some kind of media in between sender
medium,
and receiver machine.
mm,
Then
the
there
medium,
should be some data,
some data.
and
Okay,
then there should be a protocol, like as I had
a
given you the
protocol.
example yesterday, that here I am speaking in
Yes.
English, right? So some kind of rule should be there that both machine will follow. This can be the basic components of network, and after that there are so many things. And type of communication, okay, in the type of network we have seen LAN and WAN. If I have implemented network in a small geographical area, that is LAN. In large geographical area, that is WAN. Then what is type of communication? And two things are there, type of communication and mode of communication. Who will explain this? Types of communication.
Yes,
Reliable
we.
and non-reliable.
No.
I would say
Unicast,
through
Yes,
through
Duplex
unicast,
wire.
and haptoplex.
broadcast, multicast,
unicast, multicast, and
Broadcast.
broadcast,
broadcast. In IPv6,
and
anycast also.
Any cast for
Okay.
IPv6. Okay.
Unicast means
One to one
one to one.
one to one. If there is one sender and one,
receiver.
that type of communication is called
Unicast.
great. And multicast,
One to
One
One to
many.
to
many.
group of receiver.
One to many.
One
one
to
to
many.
many communication. Very good. And broadcast,
One to all.
one to all. So right now we are connected through Google Meet. This is which type of communication?
Multicast.
Why not broadcast?
Because we are only intended receiver can join this link, and we are not. I mean, not everybody is allowed to join.
Okay, right now I am speaking. I am doing broadcast or multicast. See the definition of
You're doing,
broadcast. It is not
yeah.
one to all. This is one to all within the network. In the network. One to all means one to everyone. Like if I am going to send something, it is going to be
Broadcast.
received by everyone.
Broadcast.
Yes. I'm doing broadcast, not
Yeah.
multicast. Our WhatsApp group is multicast. If I'm putting something in my WhatsApp group, that is multicast.
Sir, I'm not understanding, sir. See, we are in a network. You are saying when you're speaking, we are all listening. That is broadcast. But when you send a message in WhatsApp group, then also everybody is there in that group. Everybody can receive the information. Then how it is multicast?
But in my WhatsApp, there are so many other people also who is not in the group. So they are not receiving, na?
But right now we are in a Zoom meeting. It's only those who have the password who can join the meeting. That's why
Because
I was thinking that.
I have shared the meeting link in multicast group, correct? Now you guys have joined.
What?
Now this is our
Yes.
network. In network we all are connected. Whoever are going to
Uh-huh.
send any information, it will be received by all. This is one
Everybody.
to all.
Okay. Okay. Makes sense.
Right?
Okay.
Like when I am talking to you, this is going to be unicast.
Sir, no, sir. Let's take this way. You are in a part of a WhatsApp group. You are sending a message, and when we say that WhatsApp group is a network, in that everybody can receive that message. Then it's a broadcast, right?
Yes, that is broadcast. If I am sending something to all my WhatsApp contact, that is going to be broadcast. And if I am putting something in the group, it is going to be multicast.
Okay, now coming to this example, like Google Meet. This Google Meet, I am saying like it's a multicast because only the PM networking students are joining the call and not any outsider. In that sense, I'm telling it as a multicast. Only intended receiver can join the call.
And I am talking about after joining, after forming the network.
Okay. So
Yes.
after forming the network, yeah, it is broadcast. Okay. So again, like so when we explain things, we have to tell the context as well, like
Correct.
this. Okay. Thank you, sir.
So we have three types of communication: unicast, multicast, and broadcast. Unicast, simple one-to-one, one-to-many, and broadcast, one-to-all. Earlier, most of the technology was working on broadcast. Like remember, RIP version 2. How many? RIP version 1. How many of you know about RIP version 1? RIP version 1 works on broadcast. RIP version 1 is going to
Okay.
send their all messages on broadcast address. But RIP version 2, which is the extension of RIP version 1, the newer version, sends their messages on multicast. All the technologies are moving from broadcast to multicast. In future, you will not find broadcast. Even in IPv6, we don't have anything like broadcast. It is in IPv4. Based on IPv4 network, we have these three types of network: unicast, multicast, and broadcast. What is the benefit of moving from broadcast to multicast? CPU. Right? We are saving the CPU. Soon you are going to understand one thing, that let's suppose this is one PC and this is another PC. These are two PCs. MAC address of this PC is A, MAC address of this PC is B, IP address of this PC is 10.1.1.1 and IP address of this PC is 10.1.1.2. Right, let's suppose there is one book, CCNA book on this laptop, this PC, or any movie, anything. I want to send this to PC2. I want to send this to PC2 from PC A. So I will generate some kind of request here. My request will be generated at any layer of OSI model, depending on what application you are using, what software you are using, what protocol you are using. If you are using FTP, file transfer protocol, so FTP works at which layer?
Application.
FTP works at
Application.
application layer, right? So at application layer, my data, actual data will be generated on this PC. But this will be not directly sent to PC number 2. Now encapsulation will happen. As I told you, your letter will be first put it into the envelope, and then on the envelope you are going to add the address. Anyone knows the IP port number of FTP?
21, sir.
Right? So at layer 4 there will be source port and destination port. At layer 3 there will be source IP and destination IP. At layer 2 there will be source MAC and destination MAC. This is encapsulation. Adding extra information with actual data is called, this process is called encapsulation. So whenever a machine sends any data, they perform encapsulation. The machine which is generating the data will perform encapsulation, and the receiver machine, PC2, who is going to receive the data, will perform decapsulation. Because at the end this machine need what? This actual data only. This machine don't need port number or IP address or MAC address. At the end they need this information. So this PC is going to remove this all extra information. So again, removing extra information from the actual data is decapsulation. So encapsulation and decapsulation is happening. If you are sending something on broadcast address, then everyone in the network will be performing decapsulation. at all the layer, at layer 2, then layer 3, then layer 4. And then they will get to know at layer 4, oh, it's not for me. But if you will send same data on the multicast, then only the machine which are the part of that multicast group, those are joined that multicast group, will perform decapsulation. Rest all will drop the traffic maybe at layer 2 itself. Yes, at layer 2 only. Right, so some in the multicast we are using less CPU. My devices are going to use less CPU. I will explain this in more detail later. Okay, so nowadays, remember for now, nowadays we are moving from broadcast to multicast. About all the streaming companies or softwares like Netflix, Prime, these applications not broadcast their movies, their videos, multicast. They multicast. Even I am uploading video on YouTube. YouTube is not broadcasting it. YouTube is multicasting it. Multicasting means here I have one server. Right on this server there is a movie, and this server is connected with one router, and here I have so many users connected through switch.
So multicast is more secure than broadcast, right?
Right.
Mhm.
See, this is my network. 3 users are there, and these 3 users need to watch this movie. These 3 users, or let's say out of these 3 users, these 2 users need to watch movie. So if this server is going to unicast, then this server have to generate how many messages, how many requests, how many stream. It have to stream twice, one for this, one for this. If this server will broadcast, then this third PC will also receive it. This PC will be also using their CPU. It will be performing decapsulation. But if this server will instead of broadcast, if it will multicast, if it will send this message on a multicast address like 224.0.0.1, let's say, right, then who will receive it? This stream will be received by those machines which are part of this multicast group, who have already joined this multicast group. These machines are going to request to router, hey, I want to join this multicast group. Then router will allow them, okay, you are the part of this multicast group. Whenever I will receive any multicast stream on this multicast address, I will be sending to you guys. It is going to like that. Right, so in the network you need all types of communication. You need one-to-one, many time you need one-to-one communication, then multicast, again broadcast as well. But as I told you, we are moving from broadcast to multicast. So don't worry if you have not understood anything in multicast or broadcast. We will have detailed discussion on it. You will understand how it will reduce the CPU. For an example, I can give you one more example. Let's suppose I have 4 routers, because most of you are working professional. So you already have the basic knowledge of networking. You can understand. Let's suppose here I have 4 routers, and these all routers are connected through a switch. Why I don't want to explain this now, because maybe some of you don't know the encapsulation and decapsulation. R1, R2, R3. Right, and we want routing between router 1, router 2 and router 3. Here we want routing. These routers should exchange the routes. So if you will configure RIP version 1, which works on broadcast, then your router 4 will be also using their CPU. Even RIP is not enabled on router number 4, then also it will be using CPU, because it is the part of same broadcast network. But if you will configure RIP version 2, which works on multicast, and all your dynamic routing protocols, IGP dynamic routing protocols like RIP version 2, EIGRP, OSPF works on multicast only. So if your routing protocol is working on multicast, then router 4 will be not using your CPU. How? You will understand that. In dynamic routing protocol also you will see, right? Because when I will start any dynamic routing protocol EIGRP, the first thing is multicasting behavior, because routing protocol works on multicast. Now we have next term, which is mode of communication. Right, see here we have seen types of communication. Now I am saying modes of communication. First of all, tell me what is the difference between types and modes.
Types means how and mode means way.
Modes means
Way.
Medium.
one minute. Wait.
Sir, bar and wireless.
It should be like simplex, duplex, half duplex, full duplex.
But what is the difference? Type versus mode.
Yes, modes means way. Way means rasta. How many ways are there to send or receive data, like
Two, two.
road, like
It's
highway,
it's two. It's two ways.
right? Way like
It's,
road. How many roads are there from your home to market? So if there are 10 roads, right, you can choose any one, the best one. That is mode, right? And we have
Mhm.
three modes. Number one, first one is
So what is the type then?
type is clear with name only. Type. How many types are communicated? Types. You don't know the meaning of types? Matlab
No,
tarika.
The first one is simpler.
no, sir.
Tarika.
Like you
Tarika.
told, no, no, sir. I'm not from Hindi background. I'm from Chennai.
Okay. So do one thing after the class, just do basic research on type. What is the meaning of type? Type means tarika. I am expecting you guys should know the meaning of type. It's clear with your name only.
No,
Type
sir.
means
Type. No, sir. Type is fine, but you said you asked a question, right? What is the type versus mode?
mhm.
What is it?
So
So for that, like, hmm,
type is clear with this word only. Type.
okay, just type. Yeah. Okay.
Nothing here.
Fine, sir.
Right? Means how many types are there to send the data? Type 1, type 2, type 3, like that. Okay. And modes means the way. How many ways are there? First mode is,
You didn't tell me to go to after
please
class.
put yourself on mute.
After class.
Simplex. Then half duplex and full duplex. Who will explain?
Simplex is like one way communication, like a radio, TV, like that broadcast.
One
And
way of communication means
half,
a sender device can either can only send the data, and receiver device can
yes,
only receive the data. Sender device can never send the data, like your keyboard. Keyboard is input device. Through keyboard I can only give the input. Monitor is a output device. I can only get the information. Through monitor I can't give information, like that. So one way. There is only one way. Either you can send or receive. You can't do both on same device or on same port. It is all about ports. When I'm saying sending data from the laptop means your data will exit or enter through port only. That is NIC, network interface card. Right? So port can work on either simplex or half duplex or full duplex. Right? So simplex is one way of communication, Duplex is
Two-way communication, but not at the same
communication.
time.
two-way,
Communication.
but
One direction only.
not
One,
at
one at a time.
not at a time.
Not at the same time, yeah.
Yes, not at the same instant of time. At a time, either you can send or receive. Means port can do both. It can receive the data as well as send the data, but it can't do both. Hub works on hub duplex only. That was the biggest disadvantage.
So what was the simplex? What was the simplex one?
One way, like your television.
You only receive or you
Yes.
or you send. That's it.
Yes,
Okay.
yes, exactly. So port is
Okay,
designed to either send or receive data. And full duplex?
They can
Two-way
send and receive
communication.
at the same time.
Two-way at same time.
Communication.
And
Yes.
nowadays all ports works on, all
Same
networking
thing.
ports
Duplex.
works on full.
Full duplex.
Same thing.
Yes, on full duplex. These are some basic networking terms. Now, one more thing. Let's talk about very basic networking devices. So, who will tell me first networking devices, the smallest networking devices?
A hub.
Okay, hub. Anything else?
Switch. Bridge and switch.
Switch, hub, those are big device by the way.
Network interface card, NIC.
Exactly. First one is NIC.
Mm.
Network
Interface card.
Interface card.
interface card. If I will ask you how many IP addresses are there in your laptop, what will be your answer? Or how many MAC addresses are there in your laptop? One?
One.
Depend of quantity of NIC.
Exactly. Depends on NIC. How many NICs are there? Answer should be whatever, how many ways are there to connect your laptop to the network. Like you can connect your laptop to network through Bluetooth also. That means there is one NIC for Bluetooth. You can connect through Wi-Fi also. That means one NIC is there for Wi-Fi. You can connect through Ethernet LAN port also. That means one NIC is there also. Right? And this NIC can be physical as well as virtual. Like on my local laptop, I have VMware. So VMware is going to create lots of virtual NIC. And if I will show you CMD ipconfig all, then you can see how many NICs are there, right? And I can configure IP address on all the NICs. This is virtual NIC VM8. This is Ethernet VMware NIC. WLAN Ethernet adapter, right? Has no any configuration. On virtual NIC, see the IP address, which is the IP of my VMware. So your laptop can have multiple NICs, and all the NICs will be having a unique MAC
IP address.
MAC address by default. IP will be configured later, right? MAC is hard coded in the see, NIC is attached with your motherboard. If you will check on Google that how NIC looks, network interface card, then see this is how your NIC looks. Are you able to see the screen, guys?
Yes, that's where the MAC address is right.
Exactly. MAC address is hard coded over here on this NIC port, right? And all the communication is going to happen through this NIC port only. like sending data or receiving data, and this NIC is directly attached with chip, motherboard, right? Which kind of connector will fit here in this port?
RJ45.
RJ45.
Exactly, RJ45. And see, different types of NICs are there. This is also what? NIC only, right? Wireless NIC can be there. Wireless NIC. You must have seen these kinds of NIC on your broadband router, home router. This is also what? NIC, right? The external NIC. RJ45. This is what? This is a connector which will fit on my laptop NIC on the LAN port. This one. Or let me see, this one. So if I am connecting two computers together, that means both the computer has NIC, both the computer has at least one NIC, then only you can connect. It can be wired or wireless, that's not matter. NIC port. And for the LAN, see, if I am connecting two computers together, that means which type of network I am forming?
LAN.
LAN, right? And the popular LAN technology which we are using nowadays is Ethernet. Ethernet is what? Ethernet is a popular LAN technology, right? This is Ethernet cable, but Ethernet is a technology, right? So many things will be configured here. This cable is called Ethernet cable. Through Ethernet cable I have connected. Now manufacturer company has assigned MAC address here. That MAC address can be A, here MAC address can be B, and you will configure the IP address 10.1.1.1 and here 10.1.1.2. All the devices maintain a routing table to forward traffic, right? This PCA is going to make entry in their table that on my this NIC a network is connected. This is the network ID, and this network ID is configured on my this port. So whenever you will send any data to any IP address from that subnet, it will send through this NIC, right? It will identify whenever you are sending any traffic to Google, your machine is going to identify that from which NIC port I need to send the data, through which NIC port I will send the data. So NIC is the smallest and first networking device. And what can be the definition of NIC? Network interface card. NIC is a...
So how do we know, sir, this is half duplex or full duplex?
You can check. You can run the command. NIC is a computer hardware component used to connect computer to the computer network. Hardware used to connect computer or any networking devices to the network. What will be the second networking devices after NIC?
Sir,
Yeah.
sir, quick thing. So you was at the beginning, you said, right, like when two desktops are connected with each other and they have IP address and MAC address, they can communicate and there is no extra configuration needed, right? That's what you said.
Yes.
But now you are saying like on the PC one, the routing table has to be present so that like the system will know based on checking the route table, it will send the packet to the system B, right? So that's what so the routing table configuration should be done, right, irrespective.
It is already configured. I will not configure routing table. All that is the default behavior that is configured in operating system. Operating system is here on the laptop, right? If there is no
Yes.
operating system, definitely they cannot communicate. You can even not configure the IP address.
And on operating system is there, but the routing table, sir,
Routing is
that's
configured in the default configuration only.
okay. It comes with the OS.
Yes.
Okay, then the routing table will be there, but for it does the routing table will have the system B IP address in that routing table?
No.
Then we have to
From
configure,
command
right,
prompt,
to send the data.
Arun, from command prompt, you can see when you type route print, you can see the routes.
Both the IP address will have one common network ID, which is 10.0.0.0. So PC1 can understand that on this port, all the IP addresses belongs to this subnet is connected. It is like that.
Okay, sir. Still, like, but still, I'm not sure, but it's okay, sir. Please proceed.
Okay,
Yeah.
okay. No problem. Just wait. You will understand.
Okay, sir.
Now, the another networking device is hub. But now understand the needs of hub. What is the need of hub? Here I have two device, two computer, let's say. I can connect them very easily together through NIC because both the computer has at least one NIC. Let's suppose one NIC over here, one NIC over here. So very easily I can connect them together through Ethernet cable. But if I have three laptops and all the laptops having one NIC, then can you connect? No, then you can't connect. Then you can't connect, right? These three laptops together, because on PC1, where is the port? Where is the NIC? Not available. So here either you can add extra NIC. Here also you have to add extra NIC. Here also you have to add extra NIC. Then you can connect three networking devices like this. If you have four networking devices, again we need 3 number of NIC, means n minus 1 number of ports NICs are required on the device to form network without having centralized device. It is going to be very complicated, difficult, expensive, right? So instead of connecting like this, here you will be using one centralized device, and the first centralized device is centralized device is hub.
Hub.
First we come up with a centralized device called hub. I can say this is second networking device. No need to learn much about hub because hub is not in use, but it will help you to understand the behavior of switch. Understand what is hub. Hub is a networking device which is used to connect multiple networking devices together. You can say hub is a centralized networking device which is used to connect multiple networking devices together. It is similar like the extension board. Extension board which we are using to charge multiple devices simultaneously. Let's suppose in your home, in the board, there is only one plug, right? Only one port. So at a time you can only charge one mobile. If you need to charge multiple simultaneously, you have to purchase extension board. What happened? Getting again echo. Okay, no, it's fine. So again you have to purchase extension board, and inside the extension board all the ports, multiple ports are directly wired. Yes or no? Directly wired like this. Similarly, hub is also like this. There is a wired inside the box, right? Let's suppose this is your hub. So on the hub you will have multiple RJ45 ports, multiple RJ45 ports, and these all ports are directly wired, nothing else. There is no any memory, no brain, nothing. These all ports are connected with each other like this, wired through one wired, or you can say like this, there is a big wire and it is connected to all the ports. And here I can connect multiple computers. Now on the hub, if I have 2, 4, 5 ports, I can connect 5 computers easily, correct? But how they will share the data? Let's suppose this is my hub, and inside the hub all the ports are directly connected with each other. All the ports are wired, and I have connected 4 laptops. How hub will make communication between them, between 4 computers? These are the port. Port 1, I can do numbering, 1, 2, 3 and 4, and 4 computer. There is no memory, nothing. Hub is not going to maintain any table. Hub even don't know about your PC. Let me tell you one more interesting thing here, guys. Whenever you will connect your networking devices to other networking devices, like whenever we are connecting our laptop to the network, the first thing, I'm not talking about IP configuration, I'm talking about cable plug-in. As soon as you will plug in the cable, you know what will happen on the machine? Your machine is going to send some kind of signal. Signal is like code, some kind of code. Why? To identify their duplex, because this is PC1. PC1 works on full duplex. This is the NIC of this PC, and this port can work on simplex, half duplex, as well as full duplex. But on which mode it is going to operate? It can operate in all the modes: simplex, half duplex and full duplex. It can operate on all the modes, but it will operate on which? That depends on neighbor port, right? If hub port number 1 of hub works on half duplex, then PC1 will also set their mode to work on half duplex because of configuration. By default, configured mode is auto. If you will take any device here, let's suppose router 1, and if I will show you the interface status of this device, here I am just connecting one PC for testing. See, as soon as I will connect, my PC is going to send signal to identify that their neighbor device port number is working on which mode. And here also you can see show interface fast Ethernet 0/0. This interface works on which mode? Works on which mode? Full duplex.
Full duplex.
If I will change here mode half duplex, if I will change the mode on router number 1 from full duplex to half duplex, automatically my PC will also change their mode, because configured mode is auto. Auto means negotiate from the neighbor device, right? If I have 2 switch or 2 router connected together, if you will change mode on one device, automatically other device will set their mode accordingly. So it will send some kind of signal message to identify the mode, and hub works on Which mode?
Half duplex.
Half duplex. Because these all ports are just wired, directly connected with each other. This is nothing but one wired. So why hub works on half duplex? Because to avoid the collision. Now there are two terms: broadcast domain and collision domain. Anyone can explain what is broadcast domain and collision domain? Broadcast means what?
Basically, all the traffic will go in the mainstream
broadcast means one to many, meaning that
domain
if you're
in
in
networking means area. Domain in
How
networking
much
means
range it can send? The broadcast message, how much range it can send? Like how much distance it can send?
okay, got it. Thank you. Domain in networking means area, and broadcast means
Network.
one to all, na?
one to everything. Yeah, one to all.
One to all.
All.
And broadcast domain means
one to everybody in the area.
Domain, area, where?
Domain.
Sir, when you say area, it's the physical space, right? Physical area.
Wait, brother, wait. Not physical area. Domain where broadcast message can
reach everyone.
Travels.
Probably.
Domain area where broadcast message can be travel. That domain is called broadcast domain. And you all know the meaning of collision, colliding something.
Yes.
So collision domain means domain where collision can be occur. Collision domain means domain where
there's possibility of
collision can be occur. So tell me here, collision can be occur or not in case of hub when I am connecting 4 computer through hub? Yes.
Yes.
Because they are connected through a wire, right? So if two PC will send data at the same time, definitely there will be
collision.
And collision kills your data.
Kills your network.
Yes. Kills the performance. So collision is bad thing. Collision is bad thing. As that's why port of hub works on which mode? Half duplex. Means at a time this port can either send the data or receive the data. It can do both, but it will not send and receive the data at the same time. It will not do same thing, both at the same time. Now PC1 is here and PC2 is here, and here is a PC3. If let's say PC2 and PC3 is talking with each other, how PC1 will get to that hey, I need to send some data to PC2, but PC2 is already sending some data to PC3. If I will send data now, then there will be collision. For that, one protocol will work here called CSMA CD. Collision sense multicast access collision detection protocol.
It's multiple access
collision detection. With the help of CSMA CD, whenever PC whose mode is half duplex need to send data will identify the link is free or not. The link is free or not. This is some kind of signal only. It will send some information, the code. I also don't know about that information. That is signal, bits. Some bits to identify the link is free or not. Whenever your machine is operating on half duplex, it will not send data directly. Before sending data, it will identify this link is free or not. How? With the help of this sensing protocol. Collision sense protocol. It is used to sense the link. that link is free or not. If two devices talking with each other, then this link will be not free. If this link is free, then only PC will send data. And sometime if two PC are going to send data, then there will be collision. Why it's happening? Because switch hub don't have any memory. Hub don't know anything about PC. Another disadvantage is, if let's say PC1 want to talk to PC2. PC1 is having MAC address A, PC2 is having MAC address B, IP address 10.1, IP address here 10.2. I want to send some data from 10.1 to 10.2. I want to send some data from 10.1 to 10.2. So PC1 will generate traffic, it will send to hub. How hub will understand? As hub don't have any memory, can hub read the address that here what is the destination address? No, hub can't read it. So what hub will do, it will forward the data from their all interface, from here also, here also, here also. This PC3 will check what is the destination IP. It's 10.2. No, this is not my IP address. My IP address is 10.3. It will discard. PC4 will also check what is the destination IP address, because PC has memory. It can understand the address. It can understand the IP address, MAC address. His IP address is 10.4. It will also discard, and PC2 will accept. When PC2 will generate reply, again hub will do broadcast. It will send one copy to all the device. So there is no security. If this is the manager and want to send living letter to this person 2, can they perform unicast? No. Hub always perform
Broadcast.
Always and always. So that's why we replace hub. We come up with another centralized device called switch, and this is your third networking device, and which is very important. Understand how switch is going to perform unicast as well as multicast as well as broadcast. The first good thing about switch is switch has memory. It can read the address that hey, what is the source, what is the destination, and guys, from here your networking is starting, right? Because there is nothing in NIC. NIC is just a small hardware, right? We have not talked about MAC address, IP address till now. Everyone knows about networking, types of network, modes type, but if hub we are not using it. But switch is your first networking device which you need to master, not only learn. You need to master it. Understand what is switch? Switch is again a centralized device which is used to connect multiple networking devices together like hub only. But switch maintain a table called MAC address table, and you need to learn this MAC address table to understand the behavior of switch. Let's say I have one switch here, and this switch has multiple ports. For now, let's suppose this switch has only 4 ports. How many ports? 4 ports. And what I told you, switch maintain which table?
MAC address table.
MAC table. MAC address table. In the MAC address table, by default, there will be no any entry. There is nothing in the MAC address table by default. Done. You can also create entry statically, right? You can tell to switch 1 that hey switch 1, on your port number 1 a device is connected whose MAC address is A or B or C. Switch need what? To send the data. See, if I am using hub here, hub need what? If hub want to perform unicast, a table where it can store the MAC address. When PC A is going to send data to PC B, there will be source address and destination address. Source MAC A, destination MAC B. If hub can understand that and it maintaining any kind of table where it has mentioned that on port number 2 a device is connected whose MAC address is B, then it can perform unicast without having any issue. Switch is going to do that. By default, forget about the static method for now. Understand the dynamic method, how switch is going to build MAC address table. Now, here I am going to connect 4 PC. When you will connect PC, nothing will happen. Only PCs are going to sense the duplex, that on which duplex my port is going to operate, nothing else. It will not send any message. It will send the signal, not the actual message, actual packet, actual frame. This is so important. If anything will be not clear to you, please just stop me and ask here. Okay? PC A, PC B, PC C and PC D. These are the MAC addresses. Done? In short, I am writing MAC address A, MAC address B, MAC address C, MAC address D. Now you know on the port number of 1, which device is connected? Whose MAC address is A. Switch only know one thing, that on my port a device is connected whose MAC address is A. What is the MAC address? So switch will maintain a table like this, that on my port number 1 a device is connected whose MAC address is A. On port number 2 a device is connected whose MAC address is B. On port number 3 a device is connected whose MAC address is C. On port number 4 a device is connected whose MAC address is D. Right, and IP address, let's say 10.1, IP address here 10.2, IP address here 10.3 and IP address here 10.4. If I am going to send any data from PC1 to PC2, source IP will be what? 10.1, destination IP will be what? 10.2. Source MAC will be A and destination MAC will be B. When this PC will send this data to switch, you know what switch will do? Switch is simply going to look up their MAC address table, that B destination MAC address is B. So B MAC address, a device whose MAC address is B is connected on which port? So in the MAC address table you can see a device whose MAC address is B is connected on port number 2. It will forward the data from port number 2 only. This is what? This is unicast, right?
Yes.
So in the hub, here I can mention that hub does not support unicast, not support multicast, only support broadcast, but my switch can perform all types of communication, unicast, multicast and broadcast. Now understand how switch is going to maintain this MAC address table, how it will build this MAC address table. Anyone have idea?
Yes. By R.
Yes, tell me.
By R sending the ARP request.
No.
Okay,
ARP is different thing.
the
Learning the port numbers.
I'm talking about dynamic. Dynamically, how switch is going to build their MAC address table?
By using the port address, port numbers.
See, whenever switch is going to receive any data on their port, let's suppose it is receiving one data on port number.
It will send broadcast MAC address.
No, listen now. Listen me now. What I am saying, whenever switch will receive any data on their port, the first function of switch is address learning. What? Address learning. When it will receive any data on port number 1, always source MAC will be what? A. Source will be always A, right? Because a device which is connected over here is using MAC address A. So switch will see, okay, this data is coming from where? It is coming from a device whose MAC address is A. Okay, let me make one entry in my MAC address table. On my port number 1, a device is connected whose MAC address is A. Until and unless switch will not receive any data on port number 1, it will not learn MAC address on that particular port. Got it? Got it, everyone?
Yes.
Yes, sir.
Until and unless it will not receive any data on their port, it will not learn MAC address. Now, when I will configure IP address here, yesterday I had told you what will happen. The first thing, when I will configure IP address, my machine is going to generate GARP, Gracious ARP. What is the purpose of Gracious ARP?
To find duplicate address.
Yes, to check the duplicate IP address, right? Whenever we configure IP address on any networking devices, first my machine is going to check that IP address is unique or duplicate with the help of Gracious ARP. In the Gracious ARP, there will be some message, some information, data like target IP address. Target IP address will be what? 10.1.1.1. Source address will be also what? Source address.
10.1.1. 10
Source
same
address will be
10.1.1.
also 10.1.1.1. And then at layer 2, source MAC will be what? A, and destination MAC will be all F, means broadcast. It is going to send this Gracious ARP request to everyone in the network. Now who will generate reply for this request message? If anyone is using this IP address, right?
Yes, sir.
If no one is using, no one will generate reply. So your PC will wait for 2 seconds. That is ARP time out. Within 2 seconds, if it will receive the reply, then it will give you the error that this IP address is duplicate, otherwise it will assign. I am not interested in that. I want to show you one thing, that when this PC is going to generate Gracious ARP and it will send to switch, switch will learn MAC address on port number 1. Yes or no? When switch 1 will receive Gracious ARP, it will make entry in their MAC address table that on port number 1, a device is connected whose MAC address is A.
Excuse me, Praful.
Go ahead.
So, when does the switch generate the Gracious ARP?
Not
When
switch generate
exactly?
Gracious ARP.
When?
Not switch generate Gracious ARP. Any device where we are configuring IP address. The purpose of Gracious ARP is IP. To check IP is unique or duplicate. And you need to perform the lab of this. You need to perform lab of this. This is your first lab.
You're gonna give us some labs
Yes.
at the end of the.
This is your first lab. See what you will do. You will use one switch, right? Where I will find switch in the networking devices, and I had told you to use this switch, 2960 switch. Here I can rename it. I can say switch 1. In the packet tracer, you will perform this lab and check the MAC address table. What is the command? So
MAC address table.
MAC address table, and you can see there is nothing in MAC address table. For now, you don't need to focus on this all information. Switch is going to maintain VLAN information, MAC address, type, and port number. But for now, you need to focus on port number and MAC address. You need to focus on MAC address and port number, that on which port number what MAC address is attached, right? And later we'll see how we can do this statically. Statically also you can build this MAC address table, but right now switch don't have any MAC address. I am going to connect one PC here, PC 1. Here is PC. Guys, you need to just copy this, okay? This lab. Understand how I am doing? Just I have taken one switch, 2960 and 2 PC. I am going to connect them together. When I will connect them together, and I have used the automatic cable. Until and unless we have not discussed the cable type, you can use this automatic cable type. Automatically, it will sense what cable I should use to connect switch and PC. While connecting PC and switch, I will be using different cable. While connecting switch to router, I will be using different cable. While connecting two routers, I will be using different cable. These ports are by default down, but automatically it will come up, right? Remember one more thing, by default all the ports of switches are up. By default all the ports of switches are up, and by default all the ports of router are opposite, down. So manually you have to up the port of router, but no need to run no such command on switch. Still you can see the MAC address table of switch is empty, right? But here you can see 2 log messages. Later you will also understand how to read this log message. This is very important for troubleshooting. This log is related to link change. This log is related to link change, and this is the priority of log. Okay, we'll understand this. Interface fast Ethernet 0/1 change state to up, right? Earlier this port was down, now this port is up, right? And there is one more thing, which is line protocol. Status and line protocol. Anyone can tell me what is line protocol? What is the difference between a status, this is a state, and this is line protocol? Line protocol of this interface is also changed to up. That means it is giving 2 log messages for one port. One is a status that,
sir,
yeah,
protocols mean like some data is transferring, like packet is going through, like that.
there is no any packet. Line protocol means it is talking about neighbor device. What I told you guys, whenever I will connect PC to switch, my PC is going to sense that on which mode I need to work. My port will work on simplex, half duplex, or full duplex, correct? For that it will send some kind of signal. So already some kind of signal is exchanged between switch and PC, and your switch now know what is the status of PC1 port. What is the status of PC1 port? Like here, let's suppose I have 2 router, R1 and R2. R1, R2, port number 1, port number 1. By default, ports of router is down or up?
Down.
I can
Down.
say fast Ethernet 0/0. Down, right? Fast Ethernet 0/0. By default port is down. To up the port, you will run command interface F0/0. It will take you on this interface, and here you will run command no shutdown. Actually by default shutdown command is running. Shutdown command is running on the interface. You will remove this command like this, no shutdown. Done. What will happen? Status of this interface will be up. Status will be up, and line protocol will be
Down.
Line protocol will be down. Line protocol is giving you the information of neighbor device, right? Means port number F0/0 of R1 is connected with F0/0 of R2. So if the status of R2 port is down, then line protocol of R1 interface is going to be down. Got it, guys? When this port will come up, when I will run this command on router number 2 also, then line protocol of port router 1 will also come up. Okay?
It basically means like if there is no neighbor device on any port of either router or switch, then the line protocol will be down state on that port. Like if on my switch port 1 there is no device, and on switch port 2 there is one PC, then only the line protocol for port 2 of switch will be up, and then line protocol will be down, because and that port is up. Like you said that basically for switch port is always up.
Obvious. Line protocol means
Okay.
the status of neighbor, right? This status is saying the administrative status, right? Administratively has configured the interface down or up, and protocol is giving you the layer 2 information. Let's suppose this cable is faulty. This cable is faulty, and both side you have run command no shut, then also your line protocol will be down. If line protocol is down and both side administratively we have configured no shut, that means what? That means there is some issue with connectivity. my physical cable is faulty or there is some error on the port connector. If line protocol is up, that means there is physical connectivity between these two devices. Physical connectivity is up. There is no any issue with physical connectivity. So here it is giving me the log, right? Log for both status, admin status, and the line protocol for both the interfaces. But in the MAC address table, you can see there is still no any.
So, sir, if the line protocol is down, that's when there is like no neighbor device is connected, or the like there is a like cable faulty or connection, like there is no connection like that.
Anything, maybe cable faulty, there is no devices, neighbor device admin port is down.
Okay, okay,
Sir,
got it.
So, sir, so
Thank
that means, sir, the line protocol is down means that there may be some CRC errors or,
Exactly, because of CRC error also line protocol will be down.
Okay.
so this line protocol decides the kind of communication, right? The simplex or sorry, half duplex or something.
See, these are the
Sir,
errors. Yes.
sir, this line protocol only decides the mode of communication, right? With the neighboring device,
Line
simplex or half
protocol.
duplex.
Line protocol decide the mode of communication, mode of port.
Yeah, that's what, sir. Line protocol only decides, right? The mode of communication.
No, I didn't say that. I said line protocol status is going to give me the information of my port, and line protocol is going to give the information of my neighbor port, that connected device port. Okay.
Sir, no, sir. Like at the beginning, you said when a device is connected to a switch, then a packet is sent from the PC to the switch, right? To know whether the 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 switch is simplex or half duplex, something to know.
Don't know. Bro, I ask you
So,
to wait for some days. These questions are illogical. I said status means the status of my port, and line protocol means status of neighbor device. That's it. I said to negotiate the duplex, it is going to send some kind of signal, and then it will decide that my port is going to operate on half duplex, full duplex, or simplex. That was my statement.
okay, sir. And okay, you said like the system will send some signals. That's it. But you didn't say that line protocol is. I mean, it doesn't or nothing. It has nothing to do with line protocol. Okay,
Okay. Okay. So see,
fine, sir.
these are the errors. Later we'll talk about these errors. These all errors are related to layer 2. If line protocol is down, that means there is issue related to either physical layer, means related to link, or related to layer 2. If there is no issue related to physical links or layer 2, then your line protocol will be always up. Later we'll talk more about this line protocol in troubleshooting. For now, here you can see the duplex, and if you will check the configure mode, that duplex is what? Full duplex. This is operational mode, that this port is operating on full duplex. But if you will check the configured mode, so interface fast ethernet 0/1 switch port, then see the duplex is configured as somewhere you will find the duplex configuration as well.
Dynamic auto.
Where it is, I'm not able to see. Please help me.
Administrative mode. Second one.
Second, no, this is another thing. Somewhere duplex should be also there. Duplex will be also there somewhere, or from here you can find interface F0/1 and duplex and put question mark. See, these are the options which I can configure: auto, full duplex, and half duplex. If I will configure duplex half here on the switch, automatically my PC is going to set their duplex half. automatically. If here mode is full, automatically it will set full. Now my question, and here I want to discuss MAC address table. How switch will build this MAC address table, and this is your lab. This is your lab. So MAC address table. So MAC address table. MAC address table is still empty. There is nothing. Now I am going to configure IP address on this PC. 10 dot 1 dot 1 dot or 10 dot 0 dot 0 dot 1. Before this, before configuring IP address, I want to see the traffic. What I will do, guys, in packet tracer?
Simulation mode.
Simulation mode. So let me turn on simulation mode. And here now I am going to configure this IP. Are you able to see gracious ARP message?
Yes, sir.
In this gracious ARP message, what will be the source address? This is the MAC address of my PC laptop. This way only you will also verify. I want you to verify that this is your first lab. This is MAC address of PC1. And switch will learn this MAC address on which port?
0. First Ethernet
F0
0
slash 1.
0/1. When it will receive this traffic, because in this traffic gracious ARP you can see source address is exactly same, right?
Yes, sir.
Exactly same. And the target IP address and source address is same. Source IP address and target IP address both are 10.1. Now I am going to play it. So it will send data to switch. And now if you will check MAC address table of switch, now if you will check MAC address table of switch, then you can see one entry is there, right? Is it the same MAC address? MAC address of PC1? Yes. On which port this
So
MAC address is?
So I have a question. So this happened only by configuring the IP address. That's it, without doing anything.
Yes, without doing anything. If PC is sending any data, if switch will receive any traffic here, it will learn source MAC address. The first function of switch is what? Address learning. And now if I will ask you how switch is going to learn address, then your answer should be from source address. Whenever a statement is so clear and crystal, whenever switch receive traffic on their interface, it checks source address and makes entry in their MAC address table that a device whose MAC address is this one connected on this particular port. Got it, guys?
Yes. So that means that once we connect a device to a switch, it learned, and we configure the IP address. It learned the MAC address from the connected device automatically, right?
Correct.
Perfect. Thank you so much.
Now in this MAC address table of switch, I have one MAC address. What it's saying? This is VLAN information. I will talk about VLAN later. This is the MAC address. Switch has learned it dynamically and on this port number. If switch has learned it dynamically, then there is a timer, MAC aging time. Means after 300 seconds, switch is going to flush it, remove it. If switch 1 will not receive any data for 300 seconds on this port, then it will remove this entry. If you want switch should store this MAC address for long, you can change the MAC aging time. You have to understand how to manage the MAC address table of switch. Whatever things are there in MAC address table, you can manage everything. Right? By default, MAC aging time is 300 seconds. And if switch is going to receive now another message, let's suppose I am sending one ICMP packet, I am going to ping, let's say 8.8.8.8 internet. Again my PC is going to send traffic to switch, and switch is going to update their MAC address table. Means timer is going to reset. Timer will reset. Let's suppose earlier it has learned MAC address on 0/1 port around 200 seconds ago. So again timer will time is going to reset, it will set time 0 for that particular MAC address. Again it will wait for 300 seconds, next 300 seconds. So MAC aging time on the switch by default is 300 seconds. Similarly on PC2 also, as soon as I will configure IP 10.1.1.2, 10.1.1.2, it is going to learn the MAC address. Now let me take you to switch 2 and let me show you the MAC address table. Now you can see in the MAC address table how many MAC addresses are there? 2 MAC addresses. Based on this MAC address table, later we will have many configuration like MAC label authentication, right? Port security, binding MAC address on a particular port. Like I want this PC1 should only allow, or this MAC address, this is the MAC address, this MAC address should be only allow on port number 0/1. So if PC1 will connect their device on any another port, switch will automatically block that. Or if I want that device with this MAC address should be always in management VLAN 100. So doesn't matter where you are connecting this PC, on first floor, 10th floor, 6th floor, in different building, it will automatically get in a dedicated VLAN. Those all things will be managed through this MAC address table. And after 300 seconds, it will clear MAC address table. You can manually clear, or otherwise after 300 seconds it will automatically clear. Now you can see there is nothing. Now again, when switch will learn the MAC address, we are done with the IP configuration. IP is already configured on both PC. IP config, IP address is 10.1 here, 10.1, and on PC2 IP address is 10.2. 10.2. When switch will learn now again MAC address table, this is empty. Now when you will send the data manually, right? When if I am going to ping PC2 from PC1, that is ping. What is ping? What is ping?
ICMP echo.
Getting connectivity.
Ping is a protocol that allows
Ping is
us
not
to
a protocol.
No, it's a command. A command
It's
that
a
allows us to
utility kind of thing.
That allows us to verify connectivity.
Or you can
To
say
check
troubleshooting.
Tool.
Yes, tool, which uses ICMP protocol. To check the connectivity, right? See, all the communication is going to happen over IP network, right? Let's suppose here I have one switch and this switch is connected with multiple end devices. So doesn't matter which data you want to send between the PC. To send any data, any information, there should be IP reachability, right? Then only you can send data. And ping used to test that connectivity, IP connectivity is there or not. So if I am going to ping PC2 from PC1 just to check the connectivity, that connectivity is there or not, you can see connectivity is there. Connectivity is there, ping is working.
Successful.
Now switch will perform unicast or broadcast? Unicast, right? See, if I am going to ping this IP address, what will happen? You know, first IP is already configured on both machine. As soon as you will say ping and this IP address, and same thing will happen while sending data, any data, HTTP, FTP, TFTP, doesn't matter. First thing my machine is going to check, hey, I need to send data to 10.1.1.2. Basic requirement of communication is source IP, destination IP, source MAC and destination MAC. Source IP, destination IP, source MAC and destination MAC. Basic requirement of communication. Machine can send any data only if machine have these all four informations. So tell me, if I want to send a ICMP request message from PC1 to PC2, I want to send, if you are pinging, that means you are generating ICMP echo request message. If I want to send ICMP echo request message from PC1 to PC2, PC need what? Source IP. Is source IP there?
Yes,
What
we
is
know
source
it.
IP?
10.0.0.1.
Source IP 10.0.0. Okay, 10.0.0.1. Is destination IP there?
Yes, we want to ping
You told, right?
10.0.0.
Yes, you told about the destination address that send ICMP traffic to 10.0.0.2. 2. Is source MAC there?
Yes.
This is the source MAC, right?
Yeah.
Now, is destination MAC there?
Yes, it is there since we connected directly to the switch.
How I will
We
check
use
that?
ARP.
Yes, ARP. Now, there is, see guys, like we have MAC address table on switch to forward the traffic. MAC address table to forward the traffic. In the MAC address table, switch store what? MAC address and port number and how it have learned and the VLAN information, nothing else. Similarly, the devices where you configured IP address, I told you one thing, that when you will configure IP on the PC, your machine is going to check duplicacy first, that this IP address is unique or not. But I didn't told you one more thing. When PC will identify that this IP address is unique, then PC will start maintaining a table called
MAC address
ARP
table.
table. A table called ARP table. As soon as you will configure IP on the machine, it will identify this IP address is unique or duplicate. If the IP address is unique, it will assign that IP address on the port and it will start maintaining ARP table. PC, router, switch, every networking devices, firewall, load balancer, all networking devices. If I am going to configure IP on the router, then router will also do same thing. First it will generate Gracious ARP to check the duplicate IP address. After that, if IP address is unique, it will assign on the port and it will start maintaining ARP table.
Sir, what are the, sorry to disturb, sir, what are the data stored on ARP table?
Yeah, I am coming on that only.
Okay, sir.
So IP ARP. Right now, see, there is no any ARP table. Even ARP table is not empty. There is nothing. As soon as I will configure IP interface F0/0, no shutdown, and IP address 10.1.1.1, 255.255.255.0, it will start maintaining ARP table. So IP ARP. Still there is nothing because line protocol of your interface is still down. And router does not store their own entry. Right? Cisco operating system does not store their own entry. Actually, Cisco operating system store their own entry. Windows operating system does not install or store their own entry. ARP table carry IP address with MAC address. IP address with MAC address. Like my IP address is 10.1.1.1 and my MAC address is A. So when you are pinging 10.0.0.2 from PC1, PC1 is going to find MAC address of 10.2 in which table? In which table?
ARP table.
In ARP table, right? ARP hyphen A. In the ARP table, is MAC address available of 10.0.0.2? Not available, right? See, in the ARP table, what is the information? IP address, MAC address. IP address, MAC address. And the ARP timeout is 4 hours. Right? If router have resolved any MAC address from the IP address, it will store that in their ARP table for 4 hours. If MAC address is not available in the ARP table, then PC cannot send any data, because what I told you, the basic requirement of communication is these 4 things. Now what will happen? Your message will goes on hold. Your message will goes on hold. See, on PC number 2 my IP address is 10.1.1.2. if I am going to ping from PC1, if I am going to ping 10.1.1.10, any IP address which is not available in my network, what will happen? Why this PC is not able to send traffic anywhere? PC is sending, but not the ICMP message. PC is sending ARP request message to resolve the MAC address of this IP address, but it is not able to find MAC address, and until unless it will not find the MAC address, it can't send any data. You can see the MAC address is not available. Even similarly on the router, this is my router connected with this PC, and on the router I had configured IP what? 10.1. So IP ARP. In the ARP table you can see this is my IP address and this is my MAC address. This is my IP address and this is my MAC address. If I will configure one IP on PC, let's say 10.1.1.2, done. Go to router 1 and check ARP table. Only one entry. If I am going to ping any IP 10.1.1.5, repeat command is there or not? Repeat is not there here. It will send 5 ICMP packet. Just a minute. And so IP ARP, it couldn't find the MAC address of 10.1.1.5. So you can't send any data to 10.1.1.5. So guys, my all networking devices is where I will configure the IP address will maintain ARP table. Will switch maintain ARP table? This switch? Will this switch maintain ARP table? ARP table.
Yes, sir. Switch and router both.
Right now is switch maintaining ARP table? This switch?
Yes.
No.
If we have set it IP on PC2, then I believe like it
No,
is
no.
having the ARP.
See,
IP, it is layer 2, so it will not matter.
exactly. Doesn't mean layer 2 and layer 3, even if it is router or layer 3 switch, until unless you have not configured any IP address, it device don't need ARP table, because ARP table store MAC address with IP address. If you are pinging to google.com, so you are telling to your device that hey, destination is Google, destination IP address. Your machine has source IP and source MAC, but destination MAC is the thing which is always unknown, right? So my devices are going to resolve destination MAC address with destination IP address, and we'll cover this in our packet flow ARP. Guys, please give me 1 minute. Any device where we configure IP address will maintain a table called ARP table, and in the ARP table it will store MAC address with IP address, right? So till now what we have understood is, if I have two PC connected together, PC1, PC2, MAC address of PC1 is A, MAC address of PC2 is B, IP address of B connected through Ethernet cable, and here as soon as I will configure IP address 10.0.0.1, my PC is going to maintain a table called ARP table, right? PC1 will start maintaining a table called ARP table. Some operating system stores their own IP address and own MAC address as well, like 10.0.0.1 is my IP address and my MAC address is A, right? After generating gracious ARP. Similarly, when I will configure IP on PC2 10.0.0.2, PC2 will also maintain a table called ARP table, and in the ARP table there will be local entry, let's say that my IP address is 10.0.0.2 and my MAC address is B. My MAC address is B. Done.
Sir, I have a question.
Go ahead.
So the ARP aging time is different for different devices. Like the workstation has different default.
Yes, it's depend on
ARP.
operating system,
Okay, okay.
right?
Uh, for
Good.
Windows, is it 4 hours or else 5 minutes?
For
Or
4 hours for Windows.
yeah, Cisco routers also 4 hours, right?
Yes. Okay. Now, if I am sending any data, even if I am saying ping and 10.0.0.2, that means I am sending ICMP request message, right? ICMP request message. ICMP request message. And you know, request message cannot send directly because there is no address. So my machine is going to add source IP here, which is 10.0.0.1. It is going to add destination address 10.0.0.2. You told about destination address. It is going to add source MAC A and destination MAC. For destination MAC, it will look up ARP table. Is entry there in ARP table? No, not there, right? So it is unknown. So your packet will goes on hold. Here I am leaving this, okay? In packet flow, I will continue from here. Clear, guys? This message will goes on hold. Why this message will goes on hold? Because this is incomplete message, right? Information is not completed in layer 2 header. Destination MAC address is still unknown. So how it is PC1 is going to resolve MAC address with the help of ARP request, that we'll discuss later. Let's come on this switch again. This is your first lab, basic lab, where you will connect 2 or 3 devices. You can test the MAC address table of switch, and now you can see in the MAC address table still we don't have MAC address table, we don't have any entry. So when it will generate entry, it will create entry when again it will receive the message. When it has received the gracious ARP, it has learned the MAC address, source MAC address. Now if I am going to ping 10.1.1.1 from PC1, why it is not working? Okay, 10.1 is not there. 10.2 ping
No,
is
10
working.
that.
10.0.0.2. 10.0.0.2.
0001.
No, on PC1 10.2, 10.1.1.2, right? So now both the machine have generated message. PC1 has generated request, PC2 has generated reply. Switch 1 has received request message over here with source address this one, and reply message with source address of PC2 on this port. That's why in the MAC address table again you will find the entry, 2 entry. This is what? This is dynamic behavior of MAC address table. Now, what is the MAC address of PC2? This one. Understand how switch is going to perform now. Unicasting. See, what will happen when I send any data from PC1 to PC2? Data, any data. Source IP 10.1.1.1, destination IP 10.1.1.2. Source IP is 10.0.0.1. Source IP is 10.1.1.2. 0.0.1. Destination IP, this one. Source MAC will be what? This will be the source MAC address. Source MAC. And destination MAC will be what? PC2 MAC address. Where it will find? It will find in their ARP table that okay, MAC address of 10.2 is this one. Got it, guys?
Yes.
Destination MAC is going to be this one. And then your PC will forward it to switch. What is the first function of switch? Learning source MAC address, right? It is going to learn this MAC address, source MAC address 00E0 on their port number 1. First function. Another function, second function of switch is forwarding, right? Based on destination address, it will take forwarding decision. Now switch is going to check their MAC address table and it will compare destination IP address in their MAC address table. Where is destination MAC address? This one in last 41A. Here it is 41A, right? This is okay. So this MAC address device is attached on, connected on 0/2 port. So switch is going to forward it from 0/2 port. This is what? Unicast.
Sir.
Go ahead.
Hello.
Go ahead.
Sir, for searching the destination from the switch, it will broadcast or multicast? Switch it.
For what? Unicast.
Searching the destination. Switch will unicast.
Searching the
for
destination. It
Means
will compare
if
destination plot their MAC address table. It will find the MAC address, destination MAC address, and port number. Where is
For the
unicast
first
or
time,
broadcast?
broadcast, no, sir.
For the first time.
No. If MAC address, destination MAC address is not there in the MAC address table of switch, then it will perform unknown unicast flooding. That is also not broadcast. That is what?
Okay.
Unknown unicast flooding. Switch will only perform broadcast if destination address is broadcast. If destination address is broadcast. For an example, here is my switch. And this switch is connected with PC1, PC2, PC3 and PC4. MAC address A, MAC address B, MAC address C and MAC address D. Connected like this. You have configured the IP addresses on all the PC and for 3 hours you have not sent any data. Okay? For 3 hours you have not sent any data. So again MAC address table of switch will be empty, correct? It is going to flush the dynamic entry. .1.1.4, right? This is MAC address table of switch. Let's suppose there is no any entry in the MAC address table of switch. It is empty. Now in this time, if I am going to send any data from PC A to PC B, source IP will be 10.1.1.1, destination IP will be 10.1.1.2, source MAC will be A, destination MAC will be B, correct?
Yes.
Right? Right, guys?
Yes.
Now it will send to
Yes, sir.
switch. Switch is going to receive it on which port? Switch is going to receive it on which port?
Port number
But Praphul, for the first time, if doesn't know the MAC address of the
Same we are talking. There is no any MAC address in the MAC address table. If PCA don't have MAC address, then the process is going to be different. I told you that will be covered in packet flow. Okay?
Okay.
If PCA is going to find MAC address for 10.2 in their ARP table and let's say MAC address is not there, then what will happen? We'll see in the packet flow, right? We'll go very deep in that. For now, there is nothing in the MAC address table of switch 1, and PC has generated this message. PC is going to send it to switch. Switch will receive it on port number 1. The first function of switch is learning MAC address. Switch is going to learn a MAC address on which port? Port 1.
Port 1.
Then second function of switch is comparing the destination MAC address with MAC address table and finding the exit interface. But this time, see, in the MAC address table of switch, there is no any entry available for B MAC address. Yes or no?
Yes.
There is no any MAC address. So switch don't know where is B. Switch don't know where is B. But this message is not broadcast. This message is unicast, correct? Guys, if destination address, either it is IP address or MAC address, if destination address is broadcast, that means it is broadcast traffic. If destination address is multicast, it means it is multicast traffic. And if destination address is unicast, it means it is unicast traffic. So my traffic is unicast, but switch don't know from where I should forward it. What is the exit interface? On which port device whose MAC address is B is connected? In this case, switch have to forward this to everyone.
Except the one, except from his own port.
Yes, except the receiving interface. Right? It will forward the traffic from their all interfaces except receiving interface. And later I will be changing this definition. Right? Right now what I am saying, it will send the traffic from their all interface except receiving interface. Later I will say it will send the message from their all interface except receiving interface in that VLAN. Right? So this way we will be updating our definition, like when we'll discuss VLAN, when we will discuss other features. For now, it will send from their all interface except receiving interface. And this particular thing is called
broadcast.
Not broadcast. What it is broadcast means destination is broadcast. This is called
but the
unknown unicast.
Unicast flooding. Means traffic is unicast. Traffic is unicast, but destination is unknown for switch. That's why switch is flooding it. Getting my point?
So it's different from broadcast.
Yes, it is different from the broadcast. In the broadcast, destination address is going to be broadcast.
But since the switch doesn't have the entry in his MAC address, it's sending it everywhere, no?
So it is sending everywhere only, na?
But
it will send everywhere except receiving interface.
So isn't that a broadcast?
Hey, what I told you, broadcast means destination address is broadcast. What is broadcast?
One to
Source
everyone.
is A and all. Destination is all F. This is broadcast. If source and destination both are unicast, that means it is unicast traffic. When switch will perform broadcasting? Let's suppose gracious ARP. GARP. In GARP, source MAC will be MAC address of PC and destination MAC will be what? Broadcast. So in this case, switch will perform broadcasting.
Okay.
When destination address is unicast and switch is behaving like a broadcast, it is forwarding to everyone. That will be unknown unicast flooding. Unknown unicast flooding means sometime interview will ask you this question: what is the difference between broadcast and unknown unicast flooding? So answer will be destination address in the traffic, in the packet. Destination address will be unicast in case of unknown unicast flooding, and in case of broadcast, destination address will be broadcast. PC C and PC D will drop it, and PC B will generate reply. In the reply, source MAC will be B and destination MAC will be A. Again PC B will send it to Switch will receive it on port number 2. Switch is going to learn B MAC address on which port? On port number 2. On port number?
Praphul, I have one doubt. Sorry to interrupt.
Yes, just let me complete.
Yeah.
Okay, switch is going to learn B MAC address on port number 2 because this time you can see it is receiving a traffic where source is B. That means it is coming from a device whose MAC address is B. And this reply will be unicast or unknown unicast flooding?
No.
It will be unicast because again
Unicast,
switch is
no
going to
unicast.
perform second function, forwarding. For that it will compare destination MAC address with their MAC address table, and you can see entry is
Yes,
here.
yes.
So it will perform unicast. Only your first packet was broadcast. Now for 300 seconds it will be performing unicast between PC 1 and PC 2. Got it? Now ask. Who was asking question?
Praphul.
Yeah.
Praphul. So you are saying this in this case, if destination is not is unknown, it will do unknown unicast flooding, right?
If destination is unicast and switch don't know the exit
Don't know the
interface.
destination exit interface, right?
Yes.
So the actual behavior of the switch is all the switch ports will be belong to single broadcast domain, right?
Yes.
So and basically it will do the broadcasting, no?
Switch will do broadcast if the destination address is broadcast only. Why it will do the broadcast? If your traffic is unicast, switch will not decide what will be the broadcast, what will be the unicast or multicast. You will decide that. The sender will decide that this message should be unicast or broadcast or multicast. How switch can decide that? Switch is just connecting multiple devices together. Switch is a centralized networking device used to connect multiple devices. Why switch will decide what traffic should be broadcast or what traffic should be multicast or what traffic should be unicast? If destination address is unicast, it will try to perform unicasting only.
Yeah, now I understand better. I always used to think that when the MAC address is not known from the switch, it's flooded. I know that it flooded everywhere except the port where it was received. But I always thought that that message was a broadcast. Now that I learned that it's an unknown unicast flood.
Exactly.
Okay. Thank you.
Switch perform 4 types of flooding: unicast, multicast, and broadcast, as well as a non-unicast flooding.
So switch will learn and do accordingly, right?
Yes. These are the two basic functions of switch: address learning and
At the forwarding.
address learning and forwarding. Now, what is the issue here? Let's suppose here I have one server. Here I have a server, and you know server is a static kind of device. It will be permanent. Whose MAC address is, let's suppose, ABCDE. Right, further switch is connected with router is connected with internet, and lots of users from the internet from other side are accessing this server. IP address is 10.1.1.10. Right, so if no one is going to generate traffic for this server for 300 seconds, then switch will flood the entry and it will perform a non-unicast flooding. In a non-unicast flooding, switch is forwarding the traffic from multiple interface. It is using more CPU. We don't want that. What we want, switch should never flush the entry for 10.1.1.10. So here I can create static entry that, hey switch, just bind EMAC address on your port number 10. Right? If this entry
Always.
is static, then there will be no any timer. There will be no any timer if this is a static entry.
But there's a command where we can use to change the
MAC aging
to change
time.
the MAC aging time, right?
Yes. If you will increase the MAC aging time, let's suppose 500 users are there and I have configured MAC aging time 4 hours, right? So MAC address table of switch is going to be large. Every time there will be 500 entry. Even I don't want that. I want if this PCB is not generating any traffic or no one is generating traffic for this PC, then why switch will store that MAC address in their table?
Okay, makes sense.
So based on our requirement, we will configure the MAC aging time. Let's suppose here we have two departments, admin department and HR department. I have VLAN 10 for admin and VLAN 20 for HR. Right, and admin department users are critical for me, right? I don't want switch to perform a non-unicast flooding, much a non-unicast flooding for admin department. So I can increase the MAC aging time for VLAN 10, but for VLAN 20 I can reduce the MAC aging time. It is going to be like that. So switch is our third networking device after hub, and next networking device is router. Now tell me, what is router? Switch is a centralized device used to connect multiple devices. What is router now?
Router for connecting different networks.
And switch works on which duplex?
Full duplex.
Hub works on hub duplex, right? Hub is a dummy device.
Yes.
Hub always perform broadcasting. Hub works at layer 1.
Layer 1.
Switch works at layer 2. Why we are
Yeah.
saying switch is a layer 2 device, guys?
Because it's based on the MAC address.
No.
Is that the reason?
Can switch understand layer 3 information? IP address? Yes, it can understand, Praphul. Can it understand application layer? Yes, it can understand. But switch will always forward traffic based on layer 2 address, MAC address, right? That's why we called switch is a layer 2 device, right? Layer device means their traffic forwarding behavior. Based on traffic forwarding behavior, we call device works at which layer. If I am saying router works at layer 3, it doesn't mean router works on IP or switch works on MAC. No. A router forward traffic based on layer 3 information, switch forward traffic based on layer 2 information. And whenever I am saying switch, that means I am talking about layer 2 switch. Remember this. We have layer 3 switch as well, right? So when I will call layer 3 switch, I will mention that MLS, multi-layer switch or layer 3 switch. When I am saying only switch, that means layer 2 switch. In layer 2 switch again, we have manageable switch, unmanageable switch. Layer 3 switch also manageable, unmanageable, like that.
Okay.
Manageable means you can manage, like you can configure a static entry, you can change the MAC aging time. In unmanageable, your switch will come with default configuration and you can't change that. That is not possible. That is unmanageable. Can't be managed by admin. Right? And on layer 2 device, then it's works on full duplex. Means at a time, multiple devices can send and receive the data. Right? Understand one more thing. What I told you, what is the meaning of collision domain? Domain where collision can be occur. What I told you, the meaning of broadcast domain. Domain where broadcast message can be travel. That was my definition. If I am not wrong. Right?
Yes.
Now, if I will talk about the hub, guys, because I don't want to start router today, I will talk about router tomorrow. Okay? If I will talk about the hub. So, hub has, or you can say all ports of hub belongs to single collision domain. See, collision domain is also similar like mode of communication, means how many ways are there. One collision means one way, two collision means two way, means two guys can communicate at a time. Three collision domain means there are three road, means three guys can walk at a time, three vehicle can travel on at a time. One collision domain means one way, only one guy can communicate, either one. So your hub has single collision domain, means if let's suppose 10 devices are connected, so all those 10 devices are in one collision domain, means only one out of these 10 devices can communicate at a time. If two devices will try to communicate, then there will be collision, because this entire domain is in single broadcast domain as well as single collision domain and single broadcast domain. But if I will talk about the hub, sorry, switch. So switch has per port collision domain. Switch has per port collision domain. So if I have, let's suppose 24 ports, if I have 24 ports switch, or like 24 ports 5 switches, and those all are combined in one stack, right? So 24 multiplied by 5 ports are there. All ports are in single broadcast domain, means broadcast message can travel from all the ports. If any device will generate the broadcast message, switch will forward it from their all ports. Later we can divide the broadcast domain as well. VLAN is a tool which is used to divide large broadcast domain into a smaller broadcast domain, but by default switch has single broadcast domain, and per port collision domain. So if I have 24 ports, that means how many collision domains are there?
24.
That means how many devices can communicate at a time? 24. Right? That means 24 dedicated roads are there between all the 24 devices. So if PC1 and PC2 is communicating at the same time, other PC can also talk without having any issue. And if I will talk about the router, so router has per port broadcast domain as well as per port collision domain. So if I have a router and this router has two ports, so remember, any broadcast message coming on this port will never travel from this port, will never exit from this port, because these two are different broadcast domain. One broadcast domain, two broadcast domain, right? So broadcast message of this domain can travel only here, broadcast message of this domain can travel only here. And if I have a design network like this is CCNA 200301 exam question, right? Question is not so easy, but I am going to make it easy for now. Let's suppose I have one router, two switches, and one hub, and two PC here, two PC here, and two PC here, connected like this. You need to tell me how many broadcast domain are there and how many collision domains are there. If anyone is thinking, Praful, why we are learning this all thing? What is the logic? We are here to understand the enterprise network. So guys, there is logic, right? Everything will get connects one day, don't worry. This is what, this is hub. This is switch 1. 1 minute, sir, 1 minute. 1 minute. Okay. Router. Yes, and these all are PCs. Tell me how many broadcast domain are there and how many collision domains are there?
Okay. Broadcast is only 2. That's easy.
2 broadcast and how many collision?
Yeah. 1, 2, 3, 4, 5, 6, 7, 8.
7.
8. 8.
8.
No, 7. Are
8.
we 8? I think.
How many?
Yeah,
7
8.
or 8?
No,
Let's
8. 8.
calculate. Let's calculate. What I told you, all the ports of switch belongs to single broadcast domain. Means these all ports are in same broadcast domain. Even this hub is also in that broadcast domain only because the hub is connected with same switch. This is also in same broadcast domain, right? Even this port of switch 1 is also in same broadcast domain. Means this is one broadcast domain. Yes or no? And this
Yes.
is another broadcast domain. And if I will talk about the collision domain, so all the ports of hub belongs to single collision domain. This is one collision domain. Switch has per port collision domain 2, 3, 4, 5, 6 and 7. So how many collision domains are there?
7.
7.
Mm.
Right? When you will understand the packet flow, like you guys had asked the question that Praphul, how ARP will get resolved if PC will not find MAC address in their ARP table, then what will happen? It will generate ARP request message, and ARP request message is broadcast. If here I have a PC MAC address A and IP address, let's say 10.1.1.1, and here PC, another PC B whose IP address 20.1.1.1. Right, so PCA can never resolve the MAC address of 20.1. Why? Because both are in different broadcast domain. Even let's suppose PC1 is using IP 10.1.1.1. If I will configure IP 10.1.1.1 here on also, will it give you the error, duplicacy error, that this IP address is duplicate? No, it can't
No,
give
no.
you the error. Why?
No. It's a
Because
different part.
to check the duplicacy, it is going to generate gracious ARP. Gracious ARP is a broadcast message, and this PC is in different broadcast domain. So gracious ARP of PC2 can not enter in this broadcast domain. Yes or no?
Yes, sir.
Their broadcast message will travel in this area only.
Sir, can you tell me the broadcast domain calculation again? I'm not understanding.
I said router has per port broadcast domain. Switch, all ports of switch belongs to single broadcast domain, and all ports of hub is also belongs to single broadcast domain. So this is one broadcast domain.
Sir,
Hmm.
sir, let's say for the router, each port is on broadcast domain. So now
Exactly.
that one, okay, now for router, if you see, there are two broadcast domain, like there are two ports, so there are two broadcast domain. Now for switch, a switch is one broadcast domain, so 2 plus 1, 3. And for hub, it's a single broadcast domain. So for hub, 3 plus 1, 4. So totally 4, right?
This one is one broadcast domain. According to you, this one is one broadcast domain, and this one is one broadcast domain. That means switch has per port broadcast domain. Two ports are in different broadcast domain. I didn't say that. I said switch has.
No, sir. No. I mean, let me tell you again. So I was saying for router, okay, now for broadcast domain calculation, I'm starting with the router.
Okay.
Router, it has two ports. So I'm saying, I'm counting it now. Okay, so 1, 2. So 2 broadcast domain plus, now coming to switch 1. So for a switch, it is a single broadcast domain as a switch. Okay. So now 2 plus 1, it is 3. Okay.
2 plus
Now,
1, 3.
yes.
Now, when you're talking about the switch, you don't talk about broadcast
Switch
domain. The
is in
switch don't
same
have.
broadcast domain. Switch is connected with router. Why you are calculating like that? That okay, 3 switch are there. That means switch 1, switch 2, switch 3. It is in 3 broadcast. 2 broadcast domain are there, or 3 broadcast are domain. No, this port, this port, this port, this port, all these ports in same broadcast domain. You are calculating in
Yes.
wrong way.
I'm
You should
calculating for each switch.
no,
So each
see
switch is
how
in
you should
broadcast.
calculate.
No, the link between the switch and the router is one broadcast domain. That's how you should see it.
See how you should calculate, okay? That this port is one broadcast domain, and same broadcast domain is coming here, then it is going here, then it is going here, then it is going here. Like this you should calculate. Not like switch one switch has one broadcast domain, so broadcast domain 1. Router has per port broadcast domain, so it has 2 port, that means 1 plus 2 3. Not like that.
Okay, so how to calculate, in the sense we should start from router.
Okay, if you will start from the router, then check the router port is connected with which switch, through same broadcast domain or different broadcast domain. If it is connected in same broadcast domain, then it will be considered as single broadcast domain. If here I have another router, then it is going to divide broadcast domain. Now you have one broadcast here, one broadcast domain here. It is like that.
Sir, okay, now for router 1, it is connected to switch 1. Okay, one broadcast domain.
Yes.
Now the switch 1 is connected to hub. Okay. So I'm considering it as like another broadcast domain for switch.
Switch has single broadcast domain. Both the ports are in same broadcast domain. See this port and this port, both are in same broadcast domain. So don't calculate like this, that switch has 2 ports, that means 2 broadcast domain. On the router, you will calculate like that if router has 3 ports, that means 3 broadcast domain are there.
I understand. I understand what he means. He's trying to he trying look the way you should count when we're talking about the broadcast domain. Just count the one with the router. When it comes to the switch, it's on. You just count like collision domains. Don't count broadcast when you are in a switch environment. You understand what I mean?
I mean, see, fundamentally, I need to know like how we are calculating the broadcast domain and collision domain, right? See, whether we need to check the port, whether we need to check the link, or whether we need to check the device. I don't know.
Check the domain only, domain area.
Yeah, that's when I asked the first question, right? Area means what you are saying, physical area, or what do you mean by domain or area? That's what I asked, right?
Physical area and logical area means if you can see it, this is physical only.
No, so what do you mean by domain?
Area.
Area means what? Like the physical area of, or basically the I mean, what do you mean by area? Area means like the physical area is what I know.
Just go and do some research. What is the area in networking, right? Like here, I can't solve this kind of question. What is area? I also don't know how to explain. Even this is networking class, brother. How I can teach you the definition of area, or how I should explain the area? Area means the
Some space.
yes, some space where network is implemented, like building.
No, sir. Yeah, sir. But you are saying like switch is in one domain, router is another domain. So
Yeah. So what I am saying you that if a router has per port broadcast domain, let's say this is my router, has one port. So this port is in broadcast domain. Now whatever devices, switches you are going to connect, that will be in same broadcast domain. Only router can divide it. Because this port and this port both are in same broadcast domain. So it is just extending the broadcast domain. It is not dividing the broadcast domain.
It all
What
belongs
kind
to
of
single
question you are
broadcast
asking?
domain, right?
Earlier you were asking what is the meaning of type. Now you are asking what is the meaning of area.
no, sir. Like, sir, no, sir. Like,
Yeah,
what I'm trying to get is
Arun.
like.
Yeah, if you are sending a broadcast message, if a switch have 30 ports, that 30 ports are one area, 30 ports. That broadcast message can send to the 30 ports, right? Or if it is connected to 50 ports, that 50 ports area is one broadcast domain, like that.
Okay. And
How
when a
much
switch
is
is
how much this broadcast can reachable? That is the area.
okay, when a switch is connected to a hub, okay. Now,
That,
how will you
that are
calculate the
ports.
broadcast
For
domain for the
example,
switch or hub?
hub is 8 ports and this switch is 24 ports. 24 plus 8. 32 ports are one broadcast domain.
No, he said when the switch is connected to the hub. When the switch is connected to the hub, you have only one big broadcast domain. That's it.
Yes.
When you
This
send
port
something,
and this
everybody
port,
will.
both are in
You
same
when
broadcast domain.
So it's even better when you're talking about switch and hub environment. Forget about the broadcast. It's only one. That's it. But when we talk about routers, you have two routers. You just count the number of port the router has. That's the number of broadcast domain you have.
Okay, for router, I'm getting it, but like we have to look for the number of ports in order to calculate the broadcast domain.
That's
For
it.
switch,
Yeah.
for
Mhm.
switch, when a switch is connected to a router, we don't have to look at the switch for calculating the broadcast domain. Just
Yes.
think of
Yes.
the router only. And now
Exactly.
when a
Yes.
switch is connected, now when a hub is connected to switch, you don't look at the hub. Just look at
Yeah.
the switch.
You don't count broadcast over there. It's only the number of port the switches have. That's the number of collision domain you have. That's it.
Yeah, I mean, you see, right, where I'm thinking, right? Like the main issue with me is like not with the definition, but with the way of calculating the things, or which we need to
Aaron,
look at it.
I got what you're asking. Even though if it is multiple hub, multiple switches, it's all belong to single broadcast domain
Yes.
under that network.
Yes.
It doesn't matter how many routers, how many switches you connect. It only matters when there is a router.
And
That's
what
it.
if hub is connected on that?
If you connect one more hub, it also belongs to a same broadcast domain.
Broadcast. Yes.
Then what is the collision domain?
Collision is
The
different. It have different collision